Imagine trying to piece together a puzzle about ancient civilizations, where each piece is an artifact, and knowing precisely when it existed is the key to understanding the whole picture. Radiocarbon dating is a powerful tool for this, but sometimes the dates it provides seem a little off, causing confusion in our historical timelines. Reservoir effects can significantly impact carbon-14 dating by making organic materials appear older than they actually are. This discrepancy arises because the carbon-14 content in certain environmental reservoirs, like oceans or hard water lakes, is naturally depleted compared to the atmosphere, leading to inaccurate age estimates for organisms that acquire their carbon from these sources. The core mechanism behind this phenomenon lies in the unequal distribution of carbon-14 across different global carbon reservoirs. While plants on land directly absorb carbon dioxide from the atmosphere, which has a relatively consistent carbon-14 concentration, marine organisms obtain carbon from dissolved inorganic carbon in ocean water. This oceanic carbon takes a very long time to mix with atmospheric carbon, and deep ocean waters, in particular, can contain carbon that has been isolated from the atmosphere for hundreds or even thousands of years. Consequently, marine life incorporates this older, carbon-14 depleted carbon into its tissues, resulting in a radiocarbon age that is artificially older at the time of its death. A similar effect can occur in freshwater systems where organisms ingest carbon from ancient limestone, which contains no measurable carbon-14. To accurately interpret radiocarbon dates from samples affected by these reservoirs, scientists and archaeologists must apply specific corrections. This involves using a process called calibration, which translates the raw radiocarbon age into a calendar age, often with regional adjustments. For marine samples, researchers apply a marine reservoir correction, frequently denoted as delta R, which accounts for local differences in ocean carbon-14 levels relative to the global average. This correction relies on comparing radiocarbon dates from marine samples of known age with coexisting terrestrial samples, establishing a regional offset. Understanding and applying these corrections is crucial for precise dating. For instance, the marine reservoir effect can vary by several hundred years depending on ocean currents and upwelling patterns, meaning a single global correction would be insufficient. The use of specific local delta R values, derived from regional studies, allows for much finer-tuned adjustments. Without these detailed adjustments, archaeological events involving coastal communities, whose diets often included significant marine resources, could be misdated by centuries. Therefore, meticulously accounting for reservoir effects transforms potentially misleading radiocarbon dates into precise chronological anchors, which are vital for reconstructing accurate timelines of human activity and environmental change. By applying these sophisticated correction methods, we enhance the reliability of our archaeological data, ensuring that our understanding of past cultures and environments is as accurate as possible, leading to a much clearer and more coherent narrative of history.